Welcome back, everybody. In this video, we'll be finishing up section 3.3. We just got done working on quartiles and percentiles and things, and in this section, we're focusing on box plots. So I did want to mention before we go any further that the quartiles thing, different software may give different results because there's not 100% agreement on the way that quartiles should be calculated. So the way that we've presented here should be agreeable to my math lab. So that should be fine for your homework and test purposes. All right, so moving along, we want to look at something called the 5-number summary and box plot. That's this. The minimum, the first quartile, second and third quartiles, and then the maximum. So those are the 5 numbers that would make up the 5-number summary. And the idea is that if you wanted to kind of give a quick description of what a set of data looks like, you could tell someone, okay, here's the maximum, the minimum, and then the 3 quartiles, and then that will give a pretty good sense of what that set of data is like. One other piece of useful data that is not included among the 5-number summary is what's called the interquartile range. Back in section 3.2, we'd had the range, right? That was 3.2 or 3.3. I forgot. 3.2. Back in 3.2, I believe we had the range, which was the difference between the maximum and minimum values. The interquartile range is similar but different. It is the difference between the 2 quartiles, Q1 and Q3. So what the box plot is also called a box and whisker diagram sometimes, is a pictorial representation of that 5-number summary. And it looks like this. There's a line whose length is basically the range. It's the difference between the maximum and minimum. And then sitting somewhere on that line is a box whose width is the interquartile range, the difference between Q3 and Q1. And then there's a vertical line here at Q2. And so you could think of it kind of as like a special number line in a way. It starts at the minimum of the data, ends at the maximum. And then there's a box that extends from Q1 to Q3, and Q2 is marked on the box itself. So that is a box plot, also known as a box and whisker diagram. I wanted to show you an example of that. These first couple are generated on the computer. This one I use StatCrunch to generate this one. The minimum shown here, maximum, and then Q1 and Q3 are as indicated. Okay, this one was the eruption times for the Yellowstone geyser that we saw in our last lecture. Okay, this one is the same data, but I used R software to generate this one. By default, R generates box plots vertically rather than horizontally, but that's okay. They do also show these couple of dots down here, so the picture is not totally the same. Because software here, R, has decided that these would make up outliers, and we're going to be looking at outliers a little bit later in this section. If you're interested, down below is the code that I use to generate this example, and then also the summary command in R will generate the 5-number summary for you, and also will give you the median. All right, so next what we want to do is show how to actually produce a box plot. So we're going to do that. So I've got this hypothetical list of some quiz scores ranging from 5 to 20, and we'd like to draw a box plot for that. So to get us started, I'm going to go through and collect the information we'll need, which is basically the 5-number summary. The minimum is 5, and the maximum is 20. Okay, that was easy. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values in our set of data. And so that means that 1, 2, 3, 4, 5, 6, 7 will be in the lower half and 7 in the upper half. And our median here, it looks like, is going to be 12. And then for the quartiles, the lower half has 7 values in it. So Q1 looks like it will be 11. And Q3 will be 14. All right, so then to draw the box plot, the first thing to do would be to draw the line that runs from the minimum to the maximum. So that will be from 5 to 20. All right, so that will be the extent from the minimum to the maximum. And then the next thing that we'll need is we'll need a box that runs from Q1 to Q3. That's from 11 to 14. Okay. And then let me also draw in the median as well. So the median was at 12. So a little line right there. Okay, so there's our box plot. Let me add some markers just so you know what everything is. The min was at the low end, the maximum, of course, at the high end. We had a mark at Q1 and Q3, and then the vertical line at Q2. Okay, and so taking a look at the box plot, the length of the whiskers, which is why it's called a box and whisker plot. These lines on either side, sometimes called whiskers. The lengths of the whiskers can tell you basically how variable the data set is. The width of the box represents the interquartile range and so forth. So that is a picture of what the box plot will look like. In a few minutes, I'm going to show you an example of how to generate one of these on StatCrunch. Okay, the next thing though we want to do is talk about outliers just a little bit and modified box plots. So we've mentioned outliers before, and it's worth repeating that outliers, if it's a good idea to recognize outliers when they're present, because a lot of the procedures that we do in statistics are affected by the presence of outliers. What an outlier is a data value that is outside the range or outside the group of most of the data values. Sometimes an outlier is a legitimate value. Sometimes an outlier is a result of a mismeasurement or a miscollection of data. So when there are outliers present in your data, you really want to check and make sure that they are legitimate values. Okay, so they can affect the mean and standard deviation and other stuff that we're going to learn about later in this course. So we want to talk about modified box plots. We saw an example just a minute ago with the quiz scores on how to generate a box plot. We want to see what a modified box plot is. Okay, as a reminder, the interquartile range is Q3 minus Q1. In a modified box plot, a data value is considered to be an outlier if it is at least 1.5 interquartile ranges above Q3 or 1.5 interquartile ranges below Q1. Okay, so our example will make this clearer. So we have the same set of quiz scores again. So let's go ahead and collect our 5 numbers. All right, so I've gotten the 5 number summary from our last page. To determine a modified box plot, we need to know what 1.5 times the interquartile range is. So first of all, what's the interquartile range? So interquartile range, or IQR, is the difference between Q3 and Q1. And so here that's 14 minus 11, which is 3. And so 1.5 times 3 is 4.5. Okay, so reading through the description again, it says in a modified box plot, a data value is considered to be an outlier if it is at least 1.5 interquartile ranges above Q3 or 1.5 interquartile ranges below Q1. So Q1 is 11. If we say 11 minus 4.5 is 6.5. Should have known that. Okay, so data values that are below 6.5 we would consider to be outliers. So that would suggest that 5 is an outlier. We've gone Q1, which is 11. If we were to go more than 1.5 interquartile ranges below that, values below that point, we're going to consider outliers. Q3, that's where 14 is. 14 plus 4.5 is 18.5. And then our data value of 20 is beyond that. So the 20 as well as the 5 are going to be considered outliers. So we're going to remove our outliers and we'll just draw those basically as dots on our picture. So we're going to instead make our maximum and minimum line run from 8 to 18. And then our Q1 and Q3 are 11 to 14. So we'll make a box that runs from 11 to 14 again. And then once again, our median will still be at Q2, 12. Okay, and so then we'll draw the outliers that were present, which were 5 and 20. We use dots to indicate those, of course, 1 at 5 and 1 at 20. So let me grab our other picture and put that over here next to. All right, so this is going to illustrate the difference between the two. In the first case, we had taken the original data values from 5 to 20. And then in the more recent case for the modified box plot, we had determined that any values that are more than 1.5 interquartile ranges below Q1 or above Q3, we're going to call those outliers. And so we've adjusted the graph accordingly. The decision to use 1.5 interquartiles as the cutoff between an outlier or not outlier is kind of an arbitrary decision. It's the one that our textbook author has chosen, so I want to let you know that so that when you go to do the problems in my math lab, that's basically what they're expecting. So the big takeaway here, the big point would really be if you're working with an actual set of data, you want to take a look at it, draw a dot plot or a histogram or something, and try and spot any kind of outliers that may be present to see if some kind of surveying error had occurred or a measurement error or something, because you don't want to base like your calculations like the mean or standard deviation on some outliers, because as we saw, those two in particular were sensitive to outliers. All right, so next I wanted to show you how to do a little bit of these graphical displays and calculations on StatCrunch. So that's coming now, and then we'll be all done. All right, so here I've got StatCrunch going, and I've loaded up a set of data that is family heights taken from the StatCrunch website. It's 4 columns are the father and mother, the first son and first daughter within, let's see how many families we've got, 134 families it looks like. So let's see first of all if we can get maybe some 5-number summaries for these. So let's go with stat and then summary stats. Summary stats. The data is stored in columns. Let me go ahead and collect all 4 columns here, and we'll get 4 sets of information, and then we'll click compute. All right, so now we've got everything for all 4 columns. So the fathers, that's the first row here. The 5-number summary is almost kind of out of order. They have the minimum and maximum here, then Q1 and Q3 are shown, and then the median, kind of like I said, out of order. The median is here in this first column. So you can get the 5-number summary in here by going stats and then summary stats. Data will probably be in columns, so click that. And so there's that. We've used this before to help us get the standard deviation, and you can see that here as well. All right, so let's see about getting maybe some box plots as well. So rather than going to stat, we're going to go over here to graph, and then play around with these. The one that we want for right now, though, is this one that says box plot. And then here we can do a couple of these. Let me do first just the father and first son, or actually, just one. All right, I don't know how to generate only the first and third column, so we'll go with all 4. Okay, so I compute, and there's our 4 box plots. So StatCrunch by default will put the box plots vertically. If you want to change that, you can click on options, and that's not there. I guess it needs to be, it's in here somewhere. A second, edit, there we go. All right, so draw boxes horizontally if you want the boxes drawn horizontally. All right, so there's our box plots. And then if you wish, like I said, you can copy and paste these into a Word document if you need to do that. You'll notice here that they are showing the outliers for each group as a set of dots. So there's that. Let's see what some of our other options are. You can mark the mean and median on each. Let's add that. That might be fun. All right. Okay, so there's the mean and median for each set as well. All right, so that takes us to the end finally for section 3.3. Let me know if you have any questions, and have a great day.